In this video, we're going to take a look at how the mean does not always tell the story. And so here we have the mercury levels found in hypothetical fish A and fish B. And so they've taken these samples, they've somehow tested and measured the mercury level, and they've made, do you remember what this is called? This is a histogram. It's got an axis on the bottom of numbers and numbers here. So I'm actually telling you that the mean for fish A is 0.88, the mean for fish B is 0.84. If any mercury levels above 1 part per million, then it's considered hazardous. So my question for you is, would you rather eat fish A or fish B? You can see here you have A and B. Which one would you rather eat, assuming that above 1 part per million is hazardous, below that you're okay? Go ahead and pause the video and think about it. There's a lot of arguments. You could actually argue for eating fish A or fish B. You could say, I like fish B because it has a lower mean. So overall, when I even out my mercury, I'm going to get less mercury if I eat fish B. You could also make the argument I'm going to eat fish A because I'll never have a hazardous level of mercury. I'll always be less than that. But if you look at just the mean, you'll see it doesn't tell the whole story. We can see here fish B has some, what we'll say are hazardous levels of mercury. I have a chance of getting that, but I also have a chance of having some fish that are much lower. And we call this variation. How varied is the data? How spread out is the data? And in this video, we're not going to get into it too much, but I just want to mention there's two ways that statisticians measure variation. One is with standard deviation and another was with mean absolute deviation. In this class, we'll look at mean absolute deviation later on. And it's just a way, there's a formula that they use to calculate each of these numbers. So if the number is small, that means the data is close together. If the number is larger, the data is more spread out. Now you might think, oh, these numbers aren't that much different. And you're right, we're dealing with really small numbers. And in that case, this is actually 3 times bigger than this. So this actually does show quite a bit more variation. Mean absolute deviation actually doesn't show that. Now I'm actually questioning my numbers here. It seems like this one should be smaller than this one. Yeah, I don't think this number's right, so I apologize for that. But in this video, the main idea is just want you to get comfortable with looking at graphs, thinking about graphs, interpreting them, and seeing that the mean is useful, but we also need to be looking at something else that we're going to call variation, and we'll look at that actually